All right, so what are we going to cover today? We will briefly cover RabbitMQ 3.8, which shipped last month quietly, so now would be a good time to announce it. Some future plans for 3.8, what's coming in 3.9, and a special mention of our next generation 4.0 kind of project called Nivis. So Diana, why don't you tell us about RabbitMQ 3.8?
Yeah. So RabbitMQ 3.8 is out, and we have a nice set of new features and operational improvements. The main addition is a new type of replicated queue, the quorum queues, with which we expect to address some of the issues that mirror queue have. This is not a like-for-like replacement, so all type of queues will still coexist. We have also done a fair bit amount of work to try to simplify the upgrades. Now you can run mixed version clusters during the upgrade and go from 3.7.21 to 3.8 without having to take down your whole cluster. Well, my favorite improvement of all times is that we have taken away from the broker the aggregation of the metrics and the visualization. You can use now the new built-in Prometheus plugin to export all the metrics to Prometheus and visualize them with Grafana. This has a really tiny impact on the cluster, nothing compared with what the management UI does, and is way more powerful and configurable. But if you still like the management UI or you cannot use Prometheus, we are still maintaining the management and it's available. While we did all this work with the metrics, we have also added a few new metrics that Michael will explain later. It's possible now also to use OAuth 2 support for authentication and authorization, not only with the broker through the clients, but also for the management UI and API. As in every single release, basically, we have done more work on the command line tools, and now we have better and revised health checks that help you to monitor the health of the system. And there is a new feature that is available for both type of queues, what is now the classic queue and the new quorum queue, and it's the single active consumer. You can have several consumers connected to a queue, but only one of them will be consuming messages at one point in time. The rest of the consumers will be in a waiting queue and will only take over one of them while the main consumer dies. Going back to quorum queues, why we have implemented quorum queues? You have used the mirror queues before, you know that they are not very resilient to network failures. The way they recover or not recover is not very predictable. They are also not very efficient because the internal implementation, all the replicas of the queue are connected in a ring topology, which is basically a linear algorithm. So every time you publish a message, you have to wait for it to go through all the whole cluster until you can confirm it. Quorum queues, on the other hand, are based on the RAF consensus algorithm. The way they recover from failures is predictable and very well defined. Also, the way a new leader, what was called before master, is selected is very well defined and takes very little time. If a mirror goes down, that is called now a follower or a leader, the recovery is very quick and the transfer of data is very small. And also when a follower is syncing, your queue is still available. Thing that didn't happen with mirror queues. If you had a slave syncing, the queue wasn't available during that time. That sometimes could be quite long if there has a big backlog. There is no ring topology anymore. The replication of the messages between queues is made in parallel, so it's way more faster. We have already achieved a higher throughput than with mirror queues on this first implementation. On the other hand, it will take more memory because all the data is kept on memory and in disk. So there are some trade-offs. The good thing is, given the reliability of the protocol, it's way more suited to multi-DC replication. That is something we may see in the future. So what are the main differences? Well, if you use quorum queues, you will do it because you want the consistency guarantees that it provides. And it also because it will recover from failures more better and way more predictable way. We have a better data safety model. All the data is always written to disk, which also means that we will f-sync every single message that goes to disk. So there will be a trade-off. There is a higher latency than with mirror queues. But you know that we choose consistency over availability. So if you want your data to be there and be safe, this is the option to choose. There is also, to be able to achieve this consistency, the majority of the nodes on the cluster should be available. And we recommend it for at least 3 nodes or more. The features that the quorum queue provides are very similar to the mirror queues, but not everything is available. For example, it doesn't make sense to have transient queues or exclusive queues. As the reason you will choose quorum queues, is because you want your data to be consistent and there all the time. We have implemented already some things like the letter exchange or queue length limits, but others are not yet there, like TTLs. And we have added a new feature that is not available in the classic queues. That is the poisonous message handling. If a message is redelivered to a consumer and not acknowledged too many times, you can use a policy to decide to delete the message or drop the message, so that doesn't keep polluting your system. And that's it. So, as we see, there are some differences between mirror queues and quorum queues. So the use cases are a bit more specific for quorum queues. You will choose quorum queues when you want that durability of the data, when you need persistent messages that are replicated, and when you want a high consistency on them, on all your data. You need at least a big cluster of 3 nodes. If you are using a single node or 2 nodes, you are better using mirror queues. If you can set a higher latency, this is a good choice. If you need a low latency system, it's better to go still for the mirror queues. The reason also we offer these consistent guarantees is because you need your applications to do their part. You want your applications to use publisher and consumer confirms and mandatory publishing. If they don't do that, there is no real reason to use quorum queues, as we cannot offer all the guarantees that we want. Quorum queues are not meant either to have very long backlogs to do a long-term storage system, because the way they work to offer all these consistent guarantees is that we keep a log of all the operations. So we have accumulated messages from a long time in the past. We have to keep all the data from that point in time, even if the message has been already acknowledged from the consumer and is out of the system. If you want transient queues, you don't need quorum queues either. Or if you want, again, very low latency workloads. If your system doesn't have a very big memory, maybe quorum queues is not the best option, but you still can use the configuration options to limit the amount of memory that quorum queues take. The default configuration will store everything on memory, but that can be limited, but you need to tweak it and test it. So if you want to hear more about quorum queues, Kari is going to do a talk later about this morning. So he will explain all the motivation why we did this and give an overview of the system. Mike.
Thank you, Diana. So next major feature in RabbitMQ 3.8 is simplified upgrades. We introduced a subsystem called feature flags, and feature flags are used by nodes to communicate their capabilities to their peers. So for example, if you cluster a 3.7 node together with 3.8, all nodes will behave as close as possible to 3.7. And once all of the cluster nodes are upgraded and your deployment tool or maybe operator manually enables certain feature flags, those new 3.8 features will become available on all the nodes. So this roughly works the way you would expect. So this feature is meant to simplify upgrades. We do not expect you to run mixed version clusters for days and months, but for several hours or how long it might take to upgrade a cluster, this is now an option. And blue-green deployments are still there if you want to use that approach. But rolling upgrades are, we hope that they are reasonably easy now so that most people would use them by default. So unfortunately, this cool feature does not mean that at any future point, we wouldn't introduce a break-in change that would require a cluster-wide shutdown, because one of the complications in distributed systems is sometimes you have to change the behavior of all nodes at once, unfortunately. In that case, you still have the blue-green deployment option. All right, next this is the favorite feature of several members of our team. We have built-in support for Prometheus and a set of Grafana dashboards to go with it. So it's a plugin, you have to enable it. There is nothing to configure really. You have to point your Prometheus instance at it, install some Grafana dashboards from grafana.com, and you should be good to go. So this is what it looks like. I don't expect you to read the labels or anything, but this is basically the management UI's overview page counterpart. It has more or less the same data, except now you have relevant data for all the nodes in one place, whereas previously the overview page had some cluster-wide information, but to see certain other metrics, you had to open multiple tabs with node-specific stats. So these Grafana dashboards give you a cluster overview, and it is much easier to see, say, maybe one node has a disproportionate number of client connections or things like that. Before we continue, so why do we want to use Prometheus and Grafana? Well, if you think about it, the management plugin we have today, it couples your monitoring solution with the system being monitored, which is not necessarily optimal. This way, we decouple those two things. This plugin is significantly smaller and simpler, so it has lower overhead, has to do a lot less work, doesn't do any aggregation. You can store metrics for any period of time that Prometheus and your disks, I guess, allow for. You have a much more powerful user interface. You can share your dashboards. So if you want to share some metrics with a different team, you don't have to mess with screenshots and all of that. And who has access to those metrics is orthogonal to who has certain RabbitMQ permissions. Well, lastly, because nodes that just serve their own metrics and don't do cluster-wide aggregation, failures of other nodes would not introduce timeouts for some requests, because a node only has to serve its own data, and the probability of getting a timeout is significantly lower. But we decided to not stop there. There are people in our team who really love metrics, so they decided to add more. How about Erlang memory management or inter-node communication stats? Those things were previously possible to obtain either if you know where to dig in the management UI or if you knew what relatively obscure tools to use. We also have raft metrics. And if you would like to see more metrics added, well, please talk to a member of the core team. So this is the memory management slide, and it shows you all the various heap types, their breakdown per node, allocation, deallocation rates, and all kinds of other interesting details. What the kernel sees versus what the runtime sees, which is sometimes important. Again, we just install this. It's pretty easy, and you have it for free. This is the Erlang distribution, a set of panels related to Erlang distribution. So you can see traffic rates between nodes, whether they had any backlog in the inter-node communication buffer, what nodes were connected to what other nodes over time, or trying to connect, for example. So this gives you an insight into the state of your system that actually was not really possible before. And in fact, we saw some early users last month on the mailing list who found some irregularities in the networking setup exactly thanks to this set of panels. So this is a continuation. There are even more metrics, and you can see that some of them are in red. So if they spike above a certain level, which you can configure, It means that maybe it needs operators' attention, and if things are green, then hopefully your system is in a good state. So this is, if you really want to study Raft's behavior, especially under load, this is a set of dashboard that our team uses to evaluate system behavior under stress tests. Right, so this is what is available in 3.8, not every single feature, but what we would like to highlight. So we will have some more coming in 3.8 releases before we ship 3.9. And I'm sure you are curious about what those things are going to be. Well, this is what Diana is going to tell you about.
So even though 3.8 is out, we haven't finished working on it, and it's not only bug fixes. We are working on implementing RabbitMQ for Kubernetes from Pivotal, and we are doing quite a few quorum queue improvements. As you know, it's a new feature, so it's still maturing. But we have already managed from 3.80 to 3.81 release to lower the memory footprint on a 25% for some workloads. And the CPU footprint also in a 10% for some use cases. So this already is some achievement. And we have also released with this last patch release a new RabbitMQ CTL command that you can use to rebalance the leaders across the cluster. So if after a rolling upgrade, all your leaders end up on the same RabbitMQ node, you can use this script to distribute them all around the cluster. So your load should be more balanced inside. While we are doing all this work in 3.8, we have also started to do some work in 3.9, that Michael is going to explain now.
Thank you, Diana. So what is coming in RabbitMQ 3.9? By the way, this presentation contains forward-looking statements, yada, yada, yada. Don't base any purchasing decisions based on it. This is just a couple of guesses we have. Yeah, so what is currently the plan for 3.9? So we would like to have a completely protocol agnostic core. What does that mean? Well, we support multiple protocols. We would like to support more in the future, and currently they are a little bit too tied to the original protocol that we implemented. And sometimes that introduces overhead or subtle correctness issues that honestly shouldn't be there. So those would be two benefits: improved correctness and lower overhead. And hopefully more protocols to come after that, but not necessarily in 3.9. We have a couple popular plugins. So one is the management UI. It badly needs a rewrite. It will focus more on management now that metrics are handled by Prometheus and Grafana. And there is a delayed message exchange plugin, which is also very popular. And we would like to make that distributed because it has a good natural fit with Raft and the way it is used. So what that means is you will have a single set of delayed messages in publishing, which is not node specific, basically. And that is coming in 3.9. We also have RabbitMQ Enterprise Edition. So what the hell is that? It's a set of extensions to the core open source RabbitMQ. Just to make it clear, RabbitMQ license is not going to change. But this set of extensions will be commercially licensed and targeted at companies that have, in some cases, elevated requirements, sometimes regulatory requirements around where data can or cannot be stored and so on. It will be included at some point into RabbitMQ for Kubernetes by Pivotal, or I guess we will be VMware by then. So yes, this is coming roughly around RabbitMQ 3.9. So what are some of those more advanced extensions? So many users would like to have a wide area network-friendly replication of schema, so your queues, users, permissions, all of that. So for example, you can have a hot standby, a little bit easier. Multi-data center where quorum queues. It's reasonably easy to extend that idea to, again, wide area networks. And we have some features that optimize internal traffic. For example, using Z-standard, which is a compression algorithm developed originally by Facebook. It's a really good algorithm. Like when we first implemented it, we had to bump how much data we use for testing because the thing just wouldn't register on the charts. It's unbelievably good. And using more than one link to transfer data is an area of research because a single TCP connection, well, eventually it has limitations, and that's how nodes communicate to each other today. All right, so this is roughly the highlights of RabbitMQ 3.9. So last year we presented on a research project called Nevis, and what happened to Nevis in these 12 months. So first, let's recap what is Nevis and why do we need it. So it's a schema data store. We use Mija for it today, and Mija was developed for certain workloads for hardware appliances that are not really how people run RabbitMQ or honestly most Erlang-based systems today. So Mija has certain opinionated design decisions that just don't fit very well, and working them around can only take you so far. So what if we were to keep the Mija API but replace its recovery and data merging strategy with the way Raft works, and having single operation log with, well, a lot of other Raft-based features that we can extend to multi-data center environments, but also we can, say, back up incrementally. That would be pretty cool, right? So that's what Nevis tries to achieve. Not everything at once, of course, but that's the idea. It would also slightly improve scalability. Mija is actually, it's a reasonable data store, at least for RabbitMQ's needs. But again, we believe that it can be optimized. And lastly, Mija's development is tied to Erlang OTP development, which uses yearly releases. And it's a, I don't know, 20-plus-year-old code base. There are many stakeholders. You have to reach a wide consensus before you can change anything, and it just takes forever. For a team that ships multiple patch releases a month, and we're quite proud of that, we would like to iterate on that part of the system a little bit quicker, and it's just not possible with Mija today. So what's the state of Nevis? We have a functional prototype. We have an experimental RabbitMQ branch that uses it. And we have a couple of open-ended questions. So one is RabbitMQ has transient entities, so your exclusive queues and so on. They do not make sense in the context of Raft, as Diana already mentioned, because why would you want to replicate with certain consistency guarantees and put everything to disk if this thing is transient by design and that client can go away anytime? So should we support those things, or should we take a shortcut somehow? And just in general, we have quite a bit of experience around optimizing Raft, but the way RabbitMQ uses Raft today and the way Nevis would use it, it has concurrency controls and transactions. It's a different workload in many ways. So how to optimize that is another open-ended question. Other than that, Nevis is doing reasonably well. It's not an area of focus for us, but it's scheduled for 4.0. So it's coming at some point. So that is it. Thank you very much, and perhaps let's open up for questions. Don't be shy.
This may sound obvious, but with your Grafana and Prometheus support, can you filter that to specific queues and exchanges?
Let me see if I've understood the question correctly. So given the state of Prometheus supports other metrics for individual queues and exchanges? Not really, because the way Grafana charts, panels we have today work, they represent the state of a node, and a node can have, I don't know, 50,000 queues, so charting that is a challenge. We can try to aggregate certain metrics, maybe, and we can add alerting, which I think is ultimately what you care about. You don't care about the state of a certain queue. You maybe care about passing a certain threshold, right? So we would be happy to discuss that and what you would like to see, but it's a problem of charting, given that a cluster can have more queues than a human can reasonably, interpret visually.
Michael, on the enterprise model that's being released in 2020, when would people have visibility of the sort of data release and the commercial terms for that?
Right. The question is, so given that RabbitMQ Enterprise Edition is coming next year, when would we have, all the, I guess, legal parts of that announced? Is this the question?
Yeah, basically.
I'm not a lawyer, so don't take what I am going to say seriously. I think once we are ready to ship, like, I don't know, a certain beta, which is not beta 1, the terms will be ready by then. I think early betas will be tested privately with certain customers, and maybe the terms there would be different, but it's above my pay grade.
Thank you.
So no one is going to ask about that RabbitMQ release produced by Rabbit. Seriously?
Let's hear it.
Well, it was our first automated release, fully done with Concourse. So there was only one click to do. He needed a bit of help with the trackpad because I didn't have a mouse, but he's really good with the mouse. But yeah, he clicked and he did release 3615, in fact. The picture that you can see in Twitter is him doing the release itself.
So it's a true story. But
Yes.
seriously though, producing a RabbitMQ release is a single click on Concourse, which is the only reason why we do multiple a month, because I cannot be bothered to do all of that manually. It's just too much work. Right, if you have more questions but prefer to ask them privately, you can find us in the hallway. Thank you very much.